In this video, we're going to talk about some sampling definitions. The first thing you need to know when we're talking about a sample is the mean. The mean is the average of all the data values in a set. So to find the mean is found by adding every data value and then dividing that sum by the total number of data values in the set. So here is our example. The heights of 7 friends are 66 inches, 65 inches, 70 inches, 65 inches, 67 inches, 60 inches, and 76 inches. What is the mean height of the friends? So what we're going to do to get started is first, we are going to add all of the friends' heights. So we're going to go 66 plus 65 plus 70 plus 65 plus 67 plus 60 plus 76. And when we add those all together, we get 469. Then what we are going to do is we're going to take that 469 and we are going to divide it by the total number of values in the data set. So there's 7 friends, 1, 2, 3, 4, 5, 6, 7 data values. So we take 469 and divide it by 7. And if we do that, we get 67. So that means the mean height of all the friends is 67 inches. The next important definition is the median of a data set. The median is the very middle number of the data. So to find the median, you list the numbers from least to greatest and then find the number that is in the very middle. If 2 numbers are in the middle, then you just find the average of the 2 numbers by adding the 2 numbers and dividing by 2. So let's take a look at how we would do that. So I'm going to start by listing the data values from smallest to biggest. So we have here the smallest number it looks like is 60. Then we have 2 65s. So we'll list both of them. Then we have a 66, a 67, a 70, and a 76. So that is our data set listed from smallest to biggest. So now we're going to work our way from the outside in to find the middle number. So 60 and 76 are on the very outside. Then if we work our way in one more, that's 65 and 70. Then we have 65 and 67. That means here 66 is the number that is in the very middle of our data set. So that means the median is 66. The next definition talks about the mode. The mode of a data set is the number that occurs the most within the data. To find the mode, you just look and see which number happens the most. All right, so if you're looking at your data set, we kind of look at our numbers. 66 only happens once. Here I have 65 happens twice. And no other numbers happen twice. So that means my mode is going to be 65 inches. If you have 2 numbers that happen the same amount of times, then both of those numbers will be the mode. If you have no number that is repeated, then there can be no mode. This next one is the mean absolute deviation. This is a tricky one. The mean absolute deviation is the average distance between each data point and the mean. This gives us an idea about how the data set varies. If the mean absolute deviation is really large, then there's a wide variation of data values. But if the mean absolute deviation is small, then there is just a small difference between all of the values. To find the mean absolute deviation, first you need to find the mean. Then you're going to subtract each data value and the mean. Next, you're going to add each answer above. And then last, you're going to divide the sum by the total number of data there are in the set. So this is a long, tricky one. So what we're going to do is first we have to find the mean. We've actually already found the mean very first problem that we did. And we went and we did that, and let's pretend like we're doing it. We're finding the mean, we're adding all the data values and then dividing by the total amount, and we found the mean as 67. Okay, so we're going to take each of our data set now. We've got 66, 65, 65, or 70, 65 again, 67, 60, and 76. And we are going to subtract each of those data values by 67. And what I think is easiest to do is you want the absolute value, but you can just do the larger number minus the smaller. So if I start with my 66, and we're going to subtract 67. So we're going to go 66 and 67 subtracted. 67 minus 66 is 1. Then we're going to take the 65 and subtract 67, or 67 minus 65. And that gives us 2. By taking the bigger number of the 2, you just eliminate having to worry about any absolute values. Okay, the next one is 70. We're going to go 70 minus our mean, which is 67. 70 minus 67 is 3. Then we have 65 again. So we're going to take our 67 minus 65. That gives us 2. Then we're going to take 67 and we're going to subtract 67. Yay, that's 0. Then we have 60. 60 and 67, so we're going to go 67 minus 60, which gives us 7. And then the last one is 76, and we're subtracting 67. So that is 9. So we found all of our variations here. 1, 2, 3, 2, 0, 7, and 9. Now, to find the mean absolute deviation, what we're going to do is we're going to take all of those numbers. 1 plus 2 plus 3 plus 2 plus 0 plus 7 plus 9. And we're going to add all of those together. So we get 6, 7, 8, 15, 24. So we get 24. And then, since I have 7 data value to find our mean absolute deviation, our mean absolute deviation is going to be equal to 24 divided by 7, and then we like to round that to 2 decimal places. So if we go 24 and divide that by 7, we get 3.42857143. So 3.43 would be the perfect mean standard deviation. So distribution of data is how the data is spread out. So you have some distributions that are really spread far apart and some distributions that are really close together. So let's look at an example of each of those. My first example of distribution would be something like this. The tallest person to ever live was 202 centimeters, or 107 inches. And the shortest person to ever live, these are full-grown adults, was 54 centimeters or 21.5 inches. To put into perspective, there are babies that are born and they are over 21.5 inches. So that is a pretty short. So this has a very wide distribution, almost 6 feet difference, or more than 6 feet difference actually in distribution. So this would be a very widespread, far apart distribution. An example of a distribution that is not spread far apart at all is thinking about a dice. On a 6-sided number cube, the numbers 1 through 6 can be rolled. Each one has the same chance of being rolled. So if I rolled a 1, I had a 1/6 chance of rolling a 1. Same thing with rolling a 2. It's a 1/6 chance. So is 3, so is 4, so is 5, so is 6. So this distribution is 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. So it's the same distribution. This distribution is not spread out at all. It's the same for everything. So that would be like a closer distribution. The next definition we're going to take a look at is population. A population is the entire group on which the data is being gathered and analyzed. It is who we are trying to study. If we're trying to figure out how much soda the average high school student drinks, then the high school students would be our population. If we want to know how many hours a week a Midvale middle school student studies, then we would look at Midvale middle school students. That would be our population. One more example that you can write down is, in a study that looks at how many hours a week a teenager spends on TikTok, the population of the study would be all teenagers. Now, in a study, it's going to be unrealistic to ask every single teenager how many hours they spend on TikTok. But we can get a small estimate and make a conclusion based off of the estimate. So our next definition is going to use that idea. A sample of the population is a small group that is picked from the population. The sample will help us get data based off of the entire population without having to ask the entire population. So we can say a sample is a more manageable representation of a larger group that contains characteristics of the population we're looking at. So the first example of a sample would be something like this. When trying to find out how many hours a week a teen spends on TikTok, a sample can be picked by asking 10 students at each of the high schools in a given city. So you can go and ask 10 different students in each of the different high schools. That can give you a good wide variety with different economic levels, different interest of students, so that you get a good sample of how many hours a week a teen would spend on TikTok. Another example of a sample doesn't have to involve people. It can involve items that you're looking at. So, to find out the caffeine levels of a certain energy drink, 10 energy drinks are used to measure the caffeine levels. So you're picking 10 energy drinks, probably from millions of drinks that are produced. That can give you a good estimate, maybe not the best because you're only looking at 10, but it can still give you an idea of what is happening to the population of energy drinks. So a random sample is a sample where each member of the population has an equal probability of being chosen. So they each have an equal chance. An example of that would be something like a teacher in a class that wants to know how many hours her class spends playing video games. The teacher will draw out of a hat the names of each of 10 students and ask them how many hours they spend playing video games. This is random because the teacher's not just calling on the people she wants to know, but there's a chance that every single person in the class could be picked to answer the question. So random means something that is chosen by chance, not a plan or a pattern. So if we had a random sample, it was a chance that you got picked, not by a plan or a pattern. So if I'm getting my sample, we like random samples because then it means that you are not trying to alternate any results or like affect the results in any way. Random data is great because it gives a better representation of the population. In this one, there's not really an example. You can rewrite the sample, random sample, if you want to, but we'll just move on to the next definition. A representative sample is a sample from a population that accurately shows the characteristics of the larger group. So, if we're trying to find out how many hours a week a teen spends on TikTok, we're not going to ask kids that are 9, 10, 11 years old because those are children. They don't represent teenagers. In this example, a study is done on a population of male adults with heart disease. A representative sample is collected that looks at 100 males that all have been diagnosed with heart disease. In this example, we don't want to look at females with heart disease. We don't want to look at males that don't have heart disease. We need a sample that represents what we are looking at. In this case, they must be males with heart disease. Proportion is a part compared to the whole, so it's like a percentage. A proportion can describe the percentages of a population that share a certain characteristic. So here's an example for you. In a study done in 2022, and this is real data, 23% of teenage students reported to spend more than 2 hours on TikTok a day. So our percent there that represents our population is 23% of teenagers, 23% spend more than 2 hours a day on TikTok. So if we're looking at teenage students as our population, then they collected a sample and found 23% of those students spend more than 2 hours a day on TikTok. So that is what a proportion is. It's a percent or a fraction that represents a characteristic of the population.